Good evening, everybody, or I should say good morning to Avinash and myself who have joined from India. It's happy to be part of this meetup group and present on the topic that we have chosen to talk. In a way, I think this pandemic helped us to connect from wherever we are. Otherwise, it would have been very difficult to do this meetup. So we should only look at everything in a positive note. So that is one of the positive side of this pandemic. Otherwise, the negative part is we're all split apart at different places. I would have loved to do this meeting in presence, in physical, as a physical meetup. I'm sure all of us would love to do that, because that networking and that physical meetup setup itself is something, it cannot be replaced by any virtual thing, any virtual form. But then things have to move on. We have to continue with what we have been doing, because it is almost close to 1.5 years since we have all been working from home, lockdown across the globe. The pandemic has affected people. We should only feel blessed and thankful that we are able to do this in spite of all this. Okay, all right. So the session will be mostly about, it's going to be 35 to 40 minutes, somewhere between 30 to 40 minutes. Don't worry, I'll not take more than that. And then I'll follow it up with Q&A. So feel free to post your questions in the chat box, and I would be happy to take them towards the end of the session so that it doesn't block the flow. Possibly for some of the questions, I might have answers in the presentation itself. So that's the mode that usually that I do. So I will be answering them towards the end. But as and when you have a question, feel free to post. That's important. And I'm assuming you're all able to see my screen, hear me clearly, see me clearly. Yes. Otherwise, please unmute, interrupt, and let me know, because it's more like I'm sitting within the four walls and talking to myself. So I never know how it is received on the other side. So that's important. Okay.
Yeah, we're all here. See you loud and clear and got the visual.
Okay, thank you. So with that, we'll get into the topic. So this is more of what is it? It is most of the discussions or the points that I'll be sharing here are based on the experiences I've had with working with various products and modules at Zoho Corp. To give an intro about Zoho itself, I'm sure some of you might know, or some of you might not even have heard of it. Zoho is a product company, SaaS-based product company, where we have products for end-to-end operation of any business. We call ourselves the operating system for your entire business. Be it from your customer relationship management product, to marketing products, to managing people, taking care of finance, or the operations, IT operations, or your other collaboration tools. So we have end-to-end products. So that's what is Zoho. And we have been in the industry for 25 years now. It's recently, just a month ago or 2 months ago, we celebrated our 25th anniversary in the organization as a company. And I have been associated with the company for 22 years. The bio is a bit older. So this is my 22nd year at the organization. So that is the short intro of the organization itself. Site 24/7, the product that I'm currently working on is the monitoring product from Zoho Corp. And that is also there in the market for close to 15, 16 years now. So it's not a startup, or it's not a small initiative that was done recently. So I'll not get into the details of that. So that's not the interest of my talk today. So that's up to set the tone of what it is and who we are and what we are here to present. So the agenda goes like this. The topics that we'll be discussing today will be, or to set the tone, I'll just give a brief of, I just have my timer on. Yeah, perfect. So we'll get into the To set the tone, I'll be talking about the evolution of application architecture itself, and then get into this DevOps meetup. So what is my interpretation of DevOps and SRE and what people do there? Then about the topic will more focus on containers. That's what we have taken. So containers, containerization, and how optimizations are done in that, and some stats and trends of what is being present in the industry and what is looked upon, and what is the key play, who's the key player. About some Kubernetes itself will have some stats, because that's the important one when we talk about containers. Then about some challenges, then benefits. There will be benefits, challenges in anything that we take. So those are some things that I'll touch upon, and then about strategies on how you can manage things. So these, I will not get into any coding details and all. That'll be too heavy for a session. But I'll touch upon what is important for the container management itself. So that's going to be the course. I'll just spend some five minutes on each of these topics. So evolution of application architecture. So how has the application evolved, the architecture itself? So because I've been in product development itself for the past 22 years. So when I started, it was how it was and how it is today. I'm sure many of you would be able to relate to that too. So when we look at a typical, the application is mostly to do with the client server architecture. So that's the base of any application. So when we look at a typical client server architecture, so this is how it used to be. There used to be the server component that resides in one corner of your physical office. And then there used to be this client where people can connect. The client side also remains within your physical premise and connect with the server and get the data. So simple client server architecture was what it was some 20 years ago. Then with Web 2.2 technologies picking up, Web 2.2 started picking up, I think way back in 2004, 2005 timeframe, where all along that time frame, web was just considered a medium of consuming content. People can just sit back and watch videos, watch news articles. But then with Web 2.0, web was not just considered a medium of consuming content, web was also considered a medium of contributing content. People started writing their own blogs and uploading. People started taking videos and photos and uploading. So now that is when cloud itself started picking up 16 years back. And now that all data is there in the cloud, you need tools to work in collaboration. You need tools to communicate. And that's when things started. So that's the client server architecture also changed. So you have your servers still in your physical office. Then the client, you can connect from anywhere in the globe through internet. That was the evolution. And then once cloud started picking up, there were a lot of cloud providers. So the cloud providers, the public cloud providers started coming, and we had different providers, AWS, Azure, Google Cloud. There are different cloud providers. And now that your servers are no longer in your physical premise, it's all elsewhere located in the cloud. And again, the client started communicating. Now, even in this setup, even after the public cloud servers started picking up, we still see even today, not everything is moved to the cloud. There are still legacy systems which people don't want to take to the cloud, and they have it on premise. And I should say it is more of, the hybrid cloud is what is in prevalent today. There is some amount of data in the cloud, and there is still some portion on premise, and still you can connect all of this together is what is predominantly available in most of the deployments today. So that is how these things have changed. And if I have to put it in a different perspective, the entire evolution, what used to be a monolith architecture, where be it your business logic, your database component, your caching and caching layer, or your user interface, all of this used to be, even though they are all different components, they all used to be in one mega implementation or one mega architecture, where it's an entire, that's what we call it as a monolith. It's one wholesome product. From this, the architecture is changing to the microservice architecture, where each of this, be it your business logic or your data accessing layer, your caching service, each of this can be a separate service. And each of these service can be started, stopped, deployed. You can do all your entire life cycle at your own time. It's not dependent on each other. So this looks very simple, or this looks very nice and easy way of doing rather than a monolith architecture. But the complexity lies in the monitoring part of this, because you will never know when which component spawns and what happens in each of them. So there are challenges in that too, which we will discuss later. But I should say the architecture, the deployment architecture or the application architectures itself have been moving from the monolith architecture to microservices. When you take microservices and containers, there are different vendors and providers. We have a Docker implementation, and we have Kubernetes architecture, which is a predominantly used one across the industry, because it is entirely dependent. That's the one that connects both on-premise and any cloud for that matter. We'll get into details and talk about them some more in depth in the further slides, but this is how it is transforming. I should say, even from here, from monolith to microservice, things are moving towards serverless. Some extent of the deployments are moving towards serverless too. People don't want even any server for that matter. I will have only functions, function as a service. I will have them only as functions deployed on any of the services that is available. I will write only as function modules that integrate any other functions that are already available as an open source, and try to build my application. At the end of the day, building an application for your end customers is what is important for any business. So how quickly you can do that is what the industry is evolving from a monolith to microservices to serverless. But serverless is not a, sorry.
What are the standards for this, for serverless? What are the standards for serverless?
Sorry. No, I think it's more like, I don't want to speak for Raji, but I feel this is an emerging thing. I don't know that there really are standards of sort for serverless. Would you say, Raji?
No, sorry, I didn't get the question. So I was.
Oh, the question was like, are there standards for serverless architecture?
Standards. Yeah, standards. Standards is more like, you have, what is that? Certain base things like which you can use. Like if you are using a Lambda function, there are standard functions. There are no typical standards like on what you want to write. It is depending on if you want to use a what do you call for authorization, I can use a module. For my payment gateway, I can use a module. So these functions are already readily available from vendors, and you can use them for, there are modules or there are solutions which are available for image processing. So you can make use of them, the image recognition that is available. So these functions, the ready-made functions that are available, can be used in your application and integrated and built. So that's where it is moving. It's more like, rather than using your infrastructure as a service, that's the you can also use your function. You don't have to worry about your server itself. So you just have to write as function, and the deployments and running them and all is taken care by the vendors. So that's how you convert your entire existing architecture or existing application into a serverless application. You can just make use of the APIs or the standards that are available, the functions that are available to build your entire application. I hope I answered. For this talk, my focus was not on serverless. I have focused more on the microservice and the containers. I'm happy to do a serverless talk any further time too. So I just brought in this, I just brought in this serverless so that to say that is an emerging technology as well, which people are moving towards, to show this evolution from monolith to microservice to serverless. So the focus will more be on the microservice part is what is going to be there in this talk. Okay.
Thanks, Raji. And just a gentle reminder for questions, I'll ask the room, go ahead and drop any questions into the chat, and I promise we'll get to the questions at the Q&A section. We'll let Raji run through the presentation, and we'll promise the Q&A at the end.
Thank you. So when we talk about these transformations, typically when you build a application and you want to build it in the cloud, that's what most of us are doing now. Any business, we want to take it to the global market, build it as a cloud architecture. What are the various layers in any cloud architecture? So this is my categorization of them. You can categorize it in any form you want. So the cloud architecture layers are typically 4 layers that we have categorized as. The top is the end user layer, which actually comprises of your browsers, your mobile phone, or your tablet, using which you access your application, the client. That is the end user layer. The next one is your application layer, where actually the business logic is hosted. You have to focus more on this because the rest of it can be used as a service. Gone are the days where you have to worry about first procuring your infrastructure component if you have to start writing your application. Today, everything is available as service. You can just make use of them and go and build your application. So that is, even there are the cloud applications are all come under the SaaS, software as a service layer. The next layer is your PaaS, platform as a service, which comprises of the caching servers, NoSQL servers, the database, or the queues, microservices, all of them come under the platform as a service layer. And the bottommost is your infrastructure layer, which is again available as infrastructure as a service, which comprises of your physical servers, virtual servers, cloud servers, your entire network component, router, switch, load balancer, firewall, all of them are now available as service. You just have to make use of the service that are provided by vendors and go ahead and build your application. So these are the various layers in any cloud architecture. So when we talk about this, why am I talking about these layers? It is important when you build an application, you run it in your container, or you run it in your own on-premise solution, or you decide to run it on your in a cloud architecture. Whatever you want to do, you have to, you run it in a public cloud, you must have complete visibility of what is happening across all these layers. That is important when we talk about cloud architecture, because the problem could be anywhere. So if you see that your website is down or your application is down, our website is the UI for your application. The problem could be anywhere. It is because of an ISP issue in one of your customer end, which is the end user layer, or it could be because a particular port in a switch is not working. In any of these cases, your users will have problems of not able to see your application or your web page. So it could be in your application, it could be in your database connection, it could be anywhere. There are 10 to 12 different places where the problem can occur when you're having it deployed in the cloud. So having an end-to-end visibility of what is happening across all these layers is crucial for managing this entire system. So that's why I categorize them, and all these things are important. So when we talk about the cloud layers, I'll come back to that layers in a minute now. So let me give a quick perspective of DevOps and SRE. This is a DevOps meetup, and I'm sure some of you are already DevOps practitioners. There are different representations for DevOps. It's a cycle from your planning to coding to build, deployment, and testing, each of them being done in a quick way. I have a different interpretation, or I have a different visualization for DevOps itself. So there used to be this role called as developer, who actually takes care of writing the code, compiling it, bundling it into a product with using a build, and see to that there are no issues in the bundle. That with that, they feel their role is over, and they pass this to another person, who's the operator, who actually takes care of deploying the build, attending to the SLAs, making sure the application is up and running, looking at the performance, make sure that the problems are fixed when there is a complaint from the customer, all those analysis. So those used to be the role of an operator. So it used to be a lot of times, because I'm sure all of us would have been in various stages, being a developer, operator could be. It used to be that it's a ball game. The problem is with you. The problem is with you. When an issue occurs, it is a blame game of you have introduced the issue or you have not done the deployment rightly. That used to be there. But with cloud picking up and things started, the deployments happening quickly, agile way of doing things, these two roles merged and became what is called as DevOps, where the DevOps is a person or the role that is being played. He or she should have some amount of knowledge of what is happening in your development to how things are being deployed. So that's how I see DevOps as. And as shown in the diagram or the picture, he or she is not a superhero to do things by themselves. They need to depend on tools. There are various tools at various stages for each of these stages, which they are dependent on to make sure that things are up and running fine. So this DevOps, with being in the cloud, there is one more terminology or one more thing that has become important, which is security, and making sure all these layers, from your development to your deployment to attending to customers, there are no issues or with respect to security, because you're dealing with customers' data. You have the customers' data being stored in your service. So you have to make sure that things are secure. One user's data is not visible to other user, and you make sure that you don't compromise on this. So that's when this DevSecOps is something that is picking up, where you make sure that security is applied in all these layers. This is DevOps. What is SRE then? So it is more of, I see it as DevOps. If a DevOps is about what to do, SRE is about how to do, kind of. So it is two sides of the same coin is how I will see them as. So to put it into perspective, DevOps mostly is connecting dev and ops, where they take care of in the product releases and with respect to configurations, and the primary focus is on the product, the delivery. But SRE is more focused towards operation oriented, where they take care of the incident responding, monitor the events, and try to reduce the fault and take care of automation. So the primary focus is more on the reliability of the site itself. That's why they are termed as SRE. So to put it in a developer perspective and a Java developer perspective, SRE is a class that implements DevOps. So that's how we could see this as. So this is about DevOps and SRE. So you be a DevOps or an SRE or an IT administrator, whatever role you play, when you have a cloud architecture, the different layers to take care, the DevOps person should have a complete visibility of what is happening across all these layers. And that is possible using tools. So that is the context with which we will move on to the next section. So I'll be here talking about more about from here on, it is more, the focus is more on the containers, the microservice architecture, containers, and Kubernetes to some extent, because that is the most popular containerized architecture that we have. So let me quickly run through some stats to give the importance of this. So these were all taken from this article that talks about the state of Kubernetes in 2020. 59% of organizations use Kubernetes in production. It's not that people are just experimenting and doing it only in development. People have started realizing the importance. They are using it in production. 64% of organizations deploy Kubernetes still on-premise. So that's the beauty of Kubernetes. You can use it to manage your on-premise setup as well as any cloud provider. You're not bound with any of the single vendor. You're not locked with a vendor. You can have the deployments spread across multiple clouds or on-premise. Kubernetes plays a major role in taking your on-premise solution to the cloud, and people have started using them. 70% cited lack of experience and expertise is the top deployment challenge. So when we talk about adopting any newer technologies, so this often comes in, and people have quoted that understanding the technology, the lack of expertise has been there in handling the deployment challenge. So that's the quote from almost 70% of people felt that. To continue the article, when I read through the article, the benefits there are a lot of benefits from Kubernetes. So I've just picked few of them and pasted here. So 56% of people felt that using Kubernetes or moving to a containerized architecture helped in improving the resource utilization. So you don't waste your resources, because often it is felt, or there are other articles and surveys and studies that claim that 30% of resources are most of the time underutilized. And when you take it to the cloud, you actually pay more for not using them, because you only use it when you sign up. You give your card when you're signing up for that cloud service. After that, every month it will be billed irrespective of your usage. And there has been studies which quote that there are a lot of resources, underutilized resources, for which you're paying more. Payment is one side. The other side is the energy consumption and the wastage of the resources itself. So moving to a containerized architecture has benefits of, it improves the resource utilization. 53% felt that it has shortened your software development cycle. If your entire software development from your ideation phase to your deployment, to coding it and to taking it to deployment, it takes some 60 days or something. Moving to a containerized architecture for a deployment, it drastically reduced to 1/3 of the time frame. So starting from your implementation. So that's what people felt, that we are able to do quicker, shorter releases. 50% of people felt that they are able to move the monolith application container to containerization using Kubernetes, because it is still connecting your on-premise too. 33% of people felt that the containerization has reduced the public cloud cost. That's something that I talked about in my resource utilization too, because cost is something which we forget about and we end up paying more. And this containerization and moving to Kubernetes, benefits of Kubernetes includes reducing the public cloud cost. 42% of people felt that they are able to move to the cloud because of Kubernetes. Even if you have an on-premise solution and you wanted to move to the cloud, it was easy for them using Kubernetes, is what people have felt. So these are some of the benefits of Kubernetes, and this is quick stats about from the article State of Kubernetes in 2020. Moving on to the benefits of containerization. So what are some of the benefits? So first we'll talk about benefits, and then we will talk about challenges. Both will be there. Okay. So benefits, if we have to talk, I'll be talking mostly with respect to Kubernetes, because that's the primary one that's being used. It is easily portable and it is easily flexible. That's a key benefit. It's not in any order, be it benefits or challenges, just numbered. It's not in any order. To give it as pointers, I've just given it. So the framework or the architecture is easily portable and flexible. You can move across any cloud. It's not that you are bound with only one cloud. A lot of time when you are locked with one vendor, it is difficult to move to other vendor. But here you can take it to a multi-cloud deployment. That is possible. And because you are on the cloud, depending on the scale, you can easily scale it up or scale it down. So faster scaling is possible. And it's a reliable solution, because it is open source. There are community groups, and there are help available for you if you face any problem. And obviously Kubernetes is one of the market leader. People are adopting it. When more people are starting to adopt, and we saw some stats also on that, you get more help and you get to see a lot of other people having it in deployment. So it becomes easy for you too. So these are some of the benefits of moving towards, adopting containerization. Let's also look at the challenges. What are the challenges? There are challenges in any work that you do, be it your day-to-day. When you are adopting challenge, being an IT administrator or a DevOps person, the challenges are lack of expertise. We also saw this in the survey or in the study too, because we don't know if you have not adopted, if you are not equipped yourself, if you have not upgraded yourself with how to use that technology, there is going to be problem in in implementation. The fear of not knowing how to use it, the lack of expertise has often been quoted in many places where that has become a challenge for adopting to that technology itself, because we are all comfortable, as that's a human tendency. We are all comfortable with what we know, and taking new things becomes a challenge for us. Then the deployment complexities. Even though we say that each of those components or each of those containers are easy to deploy by itself, the complexity lies in actually taking care of the entire structure. So that is another challenge that people face with. There is problems with deployment. And then about the monitoring part. When you take your container, so you must know how many nodes are spawned and what is the utilization. What is the, if you're using a Docker container or if you're using a Kubernetes container, there are various components in it, and you must be able to know the performance of each and every component, be it your node or your pod or your cluster or your replica set. Whatever you talk about, you have to know how it is performing. How many times they have been spawned. What is the response time at each of these layers? What are the resource utilization of your node? At a cluster level, what is the CPU utilization? At a node level, for the entire for a single node, what is the utilization? So those are some things important for you to keep in mind, and that is again a challenge, because you will not know where the problem is. When you're facing a problem, then you will be able to, it will be difficult for you to find out what it is. So performance monitoring is another challenge. Security is a major challenge. We are talking about things in the cloud. So making sure that one user's data is not visible to the other user, or now that you are having your deployment across multiple public cloud provider, you want to apply a layer of security on each of these. You want to apply some configuration rules on each of these cloud providers. It is going to be challenging because each of it has its own layer. You may not be able to have a standard configuration for all the cloud providers that you have. In which case, a lot of times, I have faced this, I'm sure some of you would have faced this too. We want to give a specific access to a specific user. It may not be possible. Sometimes things will not work. We end up giving admin access, or we end up giving extra privilege to people where it is not required. And we will never know when that will turn back as a problem, because those authorizations are not required for that person. So that level of that layer of user management is a challenge, and that is something that has to be taken care of. So security is a challenge. Loss of control. So often we say that in containerization, it's easy. Each of it is spawned and deployed, and it is I operate on my own. Each containers can operate on function on its own. But often people have felt, I don't know what is happening in each of them. I don't have a control of the entire ecosystem. So when a problem occurs, it is very difficult to find. So a sense of loss of control is something people have felt, and that is posing as a challenge. And then the scaling cost. Not every architecture would require, scaling, cost is cost is being spoken as both the benefit as well as a challenge, because it depends on your situation. Often I get this question, or in various talks, or when I talk with customers, any optimization or any deployment that you want to do, every individual's situation, every individual's business, every individual's environment is different. What works for one may not work for other. So you are the best judge, depending on what your business is, depending on what your application is, depending on who your customers are, depending on how much you can adopt. You have to decide which way you want to work. So possibly your application doesn't require a microservice at all. Just because everybody else is adopting, please don't adopt. That's not going to help you. There could be a situation where you need a dedicated server for yourself. There is a schedule that is running every 24 hours, 365 days. There is no point in then taking that and putting it as in a separate module, or trying to use a third party for that. If you feel that you building it yourself will help you in reducing the cost, then you have to do. Because a lot of times in public clouds, when you analyze the bill, you will see what are the various components that it is being built for your data storage, for your data transfer, for every bit in different forms you will be built for. So you have to analyze if you really need them. There could be situation where you know the fixed load. You know for sure that you're going to, for your application, you will have only certain number of, the load is only so and so, possibly some 200 requests per minute. You know your application, or you know your backend schedule requires only that. There is no point in going and deploying that in an auto scaling environment, because the load is not going to change. If you're going to enable auto scaling, you're going to pay more for that. There could be a situation where you don't know the load. It's going to be a New Year sale, and you're going to get a heavy load on your system. You may want to scale up and then scale down. That is your web server containers. Those cases, you can use the autoscale environment, not for a standard schedule, which you know for sure what are the schedules that are running, possibly a schedule that is running for generating a report based on the archived data. Depending on that, you have to choose. That's the scaling cost that I talk about. So it is both a positive as well as a challenge. So those are some of the challenges that we talked about. So now moving on to the monitoring needs. So to address all those challenges, as well as for various other factors, you have to take care of monitoring your entire architecture. So when we talk about monitoring needs, and when you talk about the microservice components itself, each of this is a containerized environment. The different components in any microservice architecture, your scheduler can be a container, your data collector can be in a container, your data processor can be in a container, and you get APIs connecting all these things and working. So each of these components needs to be monitored. Similarly, in a Kubernetes environment, you will have your nodes, your cluster, your main cluster, your nodes, your pods, all of them have to be monitored. So make sure the tool that you're choosing, whatever tool you choose, depending on your conditions, make sure you have monitoring for all of these components. So when we talk about monitoring, there are these three things that you have to look for. That's called as the pillars of observability. Observability is to do with monitoring. The main three pillars that you have to look for when you choose a tool for monitoring are metrics. First pillar of observability is metrics. When we talk about metrics are to do with various types of metrics are there, but the first type is availability metrics. To make sure that all the components that we talked about, be it your node or a pod or a cluster, all of them have to be up and running. And industry standards expect now 99.999%, 5 nines. We have moved from 3 nines to 5 nines. So that is the uptime that the industry is expecting. It's almost like having 100%. You can have downtime, possibly few minutes or few seconds, but that's the industry standard, or that's what the industry expects. So taking care of availability of all those components is important. But is that sufficient when we talk about metrics? No, there is this other component that is important, which is performance. There is no point in having all your components up and running if they are going to be performing very, very slow. We often say this, slow is the new down. Because if it's going to take more time, we are not going to sit and watch that. That's the industry, or in the internet era we are in. How many of us have the time and patience to sit and look through pages that are going to take forever to load? We just skip and move to the next page. Even while searching for anything in your search engine, we don't move to the second or third page. Whatever comes in the first page, we just see that, we just click some of the links and we move on. That is what is the expectancy from people. And to rank in all these things, performance is important. Performance is not an afterthought. Across all these layers, what is the response time? Why it is taking more time? So those metrics have to be collected for your containers. So both availability and performance metrics are important. So the pillars of observability can itself be talked at length. I'm just giving the key pointers of what is important here. For metrics, make sure that you could monitor your uptime and availability and the performance of all the components that you have. The second pillar is trace. Now, once you know the key metrics that are being collected, the next important thing is to find out the line of code that is having issue. or to find out the split of where it is taking more time. Suppose your application is taking, I should say 8 seconds. People are expecting it in nanoseconds, no more minutes. So industry expects 2 seconds for a page to load. And if your page is taking 10 seconds, you need to know where it is spending more time. Is it in a database call, or is it in an application code that is a loop that is taking more time, or is it in your in a particular switch or a port that is having problem? It could be anywhere. So you need to know where it is taking more time, for which tracing is important. And tracing has to be across all the application platforms. It could be your your application could be in Java, .NET, Ruby, could be in anything. Across all these, you must be able to trace. And in a microservice container architecture, the beauty is each of the container can be written in its own language. It's not even that you're writing your entire application in one language. You'll be making use of other platforms that are available, which is written in its own language. Scheduling is best done using Java, possibly. That's possibly based on my understanding and my experience, and I'm talking. And similarly, when you want to do some processing or Windows process monitoring or Windows process fine tuning, you could write it in .NET. So each language has its own specialty. And when you talk about a containerized environment, you're going to have cross language, cross platform architecture for your application. Tracing across this is important. So this is typically that's what we call as distributed tracing. Before a distributed tracing, these are all the different services. You could have an inventory service, you could have that connects with a DB, and each of this will be written in its own language. Your tool must have the capability to trace across all these layers and find out where the problem is. So that's a challenge. Distributed tracing is important. Tracing is important. That's the second pillar. Third pillar is logs. Logs has become very crucial in this distributed environment, because anything happens, the first thing what we do is we go and look at any problem. The first thing we do is look at the logs, look at access log, when it has failed, what is the response code, and then look at the application logs, and then look at the event logs. There are different types of logs we want to debug. And now in a distributed environment, your deployment is run across the globe. It is very difficult. It's not impossible. It's almost impossible, I should say. It's very difficult for the administrator or the DevOps person to take remote control of all of these missions and look at the logs. Instead, you must be able to collect all these logs and put it in one central place and look at them. So consolidating logs across server, be it any platform that you have, you must be able to collect all these logs, do some processing on top of them, and then store it in such a way you can query it easily and quickly look at what the problem is. To put it in one line, converting your unstructured data into a structured data is log management, and that is crucial, and there are tools for it which you can make use of. So the three pillars, metrics, trace, and logs, are important when you want to monitor, manage your container environment. So to quickly give some screenshots of what you may want to look at in your containerized environment, you may have to look at the health dashboard, which talks about the current status of all the live current status of all the nodes, live current status of all the pods and services, top CPU intensive pods or memory intensive pods, the problematic nodes, problematic pods. These are some received bytes and transaction bytes. These are some things you want to have all of them in one dashboard, which is called a health dashboard. See if you can have such thing. Then about the inventory. Inventory is to do with once you deploy your deploy an agent. Definitely you will need an agent. Once you deploy the agent in the main cluster, the agent must be capable of collecting all the endpoints, be it your node or pod or your service or your replica set. You must be able to collect all the endpoints and show it as an inventory dashboard. And then the main thing is the view, the business view, the one view where you can see the health of each of your components, starting from your cluster to nodes to pods. You must be able to see the health of each of them. So that is important to have. And then those are about the metrics that we collect. This is again, I'm talking about for the three pillars. For the metrics, you need to know all these details. And for the traces, you need to know the distributed trace from an application. If the application is deployed across the different other application it talks to, you have to know a trace of where exactly it is taking time, which is the HTTP call that is slow and where it is taking more time, so that you can fine tune and fix them. So distributed tracing is important. Log management, collect all the logs, store it in such a way you can quickly just log type is container logs. You must be able to get all the logs. What is the time? What is the log? And what is the container ID? Was there any problem in the log? So querying the logs across all the containers is important. That's the log management. So these three things, metrics, traces, and logs are important for you to collect. And on top of just monitoring things, you must be able to manage. By manage, what I mean, take actions. Suppose the nodes in your, the pods in your, you have the pods and you have some nodes in some pods in your node, and your pods are continuously failing and you're unable to restart. So what do you generally do? You have to go for a manual reboot of the pod. Instead, the tool that you're using should have the capability of writing them as a scheduled script. And when something goes down, you must be able to configure in such a way that you can do an automatic reboot, which will save your time and energy so that the system doesn't go down. See if your tool that you're using have these options for taking actions. Taking actions could be, this is one example. The other could be at a node level, when your CPU usage is high, 90% it has gone to. You may want to execute some commands and free up the resources. That again should be possible using some, you must be able to have some cleanup scripts and have the configuration ready such that when your CPU exceeds 90%, take this action, run the script, clear the, clean up some processes or restart a process so that my CPU utilization is taken care of. Whatever you do manually, the tool must have the capability of doing the things automatically, taking actions. It's not just for monitoring, even for taking actions, because we are almost moving from when a problem occurs, go find out what the problem is more of a reactive way of doing. The industry is moving from reactive to being proactive. You must prevent the problem from occurring. So that is the stage we are moving, and that is what tools can help you with. The AI capabilities is an added advantage, which can do automatically without you doing any configuration. So look for all these things when you're selecting a tool. Tools are important for you to maintain your containers or maintain your application, maintain your entire architecture. And when you're selecting a tool, depending on, you have to look for these things. So monitoring using the right tool is important. So that's the main thing that I wanted to do. It could be any tool, depending on your needs, you can choose the tools. In addition to all these things, when you select a tool, I always say, look for ICE. So be cool. And what is that ICE stands for is I for integration, C for customization, E for extension. So when you are choosing a tool, you have to look, I'll say what these things mean. You have to look for ICE. And if you are a person, part of a company building a tool, see if your tool has these capabilities. By integration, I mean, see, all of us, when a new tool is brought in, we are not going to replace the existing things. We have to have, there will be provision, there will be need for having multiple tools, or at least a few tools. In such cases, you must be able to nicely integrate with the in-house tool. So the tool that you select must have import-export options. So you must be able to export the data from the in-house tool and port it inside your new tool that you're bringing in, or the vice versa, reverse order. You have to export it from the new tool and import it in your in-house tool to have a single console UI. So see if your tool has integratability. That is, the export-import options are available. Customizations are important. All of us would want to make some change, some tweak. I may want to change the color of the button. I may want to change the text to whatever I want to call it. Complete rebranding option should be there, because I don't want to use the whatever is given as such. See if the tool has customization option. Even when you're building a tool, give customization option. Extensibility. We are living in this era of citizen coders where people don't want to use whatever is given out of the box. I want to extend on top of it. There has to be API support. I may write my own UI. I will just drag and drop. I don't want to have your dashboard, whatever dashboard you have. I want it in my style. I want drag and drop and build it on my own. See if the tool has that option. Or I may use your API, build it customized into the existing tool that I'm having. See if there are options for that. So give extensible, don't build it as a rigid one mega thing. Give it in such a way that there are extensions possible. And even after doing those extensions, it should work. That is what is important. Look for extensibility. So all these things are important when you're looking for any monitoring tool. There are many tools available in the market. Before I go into that, I just want to complete with this one quote that I have. This is one of my favorite books, Start with a Why. And I'm sure some of you would have read it, by Simon Sinek. If not the book, at least you must be aware of this golden circle. Start with a why. That is why, how, and what is the order that you have to look for. Any optimization or any technology adoption that you look for, you have to first start with a why. That's the core purpose. The 5 why technique, we call it as, why should I do this? Why should I adopt this technology? Then ask the question of why. You will be able to find the core purpose of why you need to do. Some places you may not want to do, or you need not do, you don't require to do just because everybody else is doing. Depending on your needs, you have to ask this. That's a core purpose. And then comes how you do, how do you do the process? Use any monitoring tool, or you want to build your own system. All that comes the how part. The core is why. Once you do these things clearly, the what, the end result is going to be how you can be successful in your business is the end result. So with that, I'm almost towards the end of the session. So we have many monitoring tools in the industry to take care of all your monitoring needs. And Site 24/7 is one such tool, which is an all-in-one AI-powered monitoring tool that lets you take care of all your monitoring needs from one single console, from your websites, the layers that I talked about, the cloud layers, website to your application, to your platform, to infrastructure layer. We have all of them in one console, on top of which you have alerting, reporting. It's all there. And it is, as I said in my introduction, it is not a new product. It's a mature product in the industry for close to 15 years now. And we are run on Zoho's data center. We have our own data centers, and we have footprints in 10 different data centers across 5 different regions, one in US, one in Europe, one in China, one in India, one in Australia. And you can decide which data center you want to use, so as to make sure that your data resides within the geographical boundary of that particular region. And being a cloud provider, we do take privacy, security, compliance very seriously. We do get all the certifications, auditing that are done every 6 months. There will be stringent auditing that takes place to make sure that all data security and privacy are taken care of. So the key takeaways from this session are, we talked about the different layers, the application architectures, from how it is evolving from monoliths to microservices, and the various layers, and the DevOps, why it is important for them to know about them, and about containers itself, the stats, trends, benefits, challenges, and the monitoring needs. And there are many tools. While you're choosing a tool, you have to be careful. Depending on your needs, you have to choose your tool. Site 24/7 is a tool that is one such tool that is available in the market. So as a token of giving back to the community, when you sign up using this URL, you can take a screenshot. We will post this in the chat too. We are giving away 6-month subscription free to users, so you can try the product for yourself. And we are happy to do a one-on-one demo of the product, detailed walkthrough of the product in a separate session. So that's the reason I didn't get into the details of the product itself here. And this is my last quote that I want to say. So there is this is called as Red Queen's quote. There is this book, Alice in Wonderland. It's a children's book. I didn't read it when I was a child, but I read it for my children. So there is this quote, and the quote goes like this: you have to be running as fast as you can in order to stay in the same place. If you want to make any progress, you have to run twice as fast as you can. This is generally applicable to any technology or any field, and to any person, any individual too. If we don't keep ourselves updated, we will be outdated. Just to be in the same place, we have to keep running. So why I'm bringing this here is technology is evolving at the organization. Culturally, we focus more on R&D, and we make sure that we include all the latest technologies in our product and pass that benefit to customers. In a personal front, it's important for all of us to, so that we don't stay outdated. We have to be updated. With that note, thank you so much for your time. I hope I haven't exceeded. I think I took 40 minutes. I'm sorry for that. So you feel free to connect with me in any of the social media platforms, and I'm open for any questions now.
Thanks, Raji. And no sweating the time. We totally stole 10 minutes from you. So I think that was just fine for time.
Okay.
And we've got a couple of questions that came in through here.
Okay.
Peter, I don't want to like paraphrase. I see you've unmuted. Go ahead.
So when we talk about serverless, I would like to understand the meetings if you want to create a deck of serverless, because there's no standards for serverless. No standards, really. And that's why I'm worried about lock-in about the cloud stuff.
Okay. I get it. So it is, see, container architecture itself, cloud has evolved now for 15, 16 years now. Container is somewhere around, it started 2004, so 8 years now. Serverless is a newer phenomenon, 2-3 years. So it will take time for it to evolve and get some standards too. So today what is available is there are different providers where they have functions, default functions that are given. And there are still a lot of research going on around it, because we are not very sure if we take that and use it, what is the benefit we get? Do we really have to do? So those things, as I said, just because everybody is talking serverless, everybody is moving their architecture to serverless, doesn't mean we have to do that. Possibly our architecture doesn't, our application doesn't require it. So we have to study, and the new startups or the newer businesses, or some standards are, by standards I mean functions. I'm sure I get your question. There aren't default standards using which you have to build this, that is not evolved yet.
Excuse me, I'm talking about the interfaces mostly. The interfaces, like if I'm going to give one example. If you look at the interfaces on AWS, you have to have an event and a context. Nobody else has that. It's proprietary. You have to use a proprietary Java inside of there, and that's really lock-in. And that's why I'm worried about this. If you have to put something on another cloud, it's different. And it's going to be a cost to move to the other cloud.
True.
Yeah, there's always, there's always decision points to be made, and there's a sort of balance of precision versus flexibility. I think that's honestly, I think that would make a great topic for like an entire meetup.
You'd probably like to see it. I would really like to see it. Really.
Okay.
Sure. I'll make a note of that.
Peter, to your point, I think one of the things that a lot of people miss is serverless is not really appropriate for the bulk of the workload in any real business application today. Like, you wouldn't implement a database application as serverless, right? But there are certain specific use cases where serverless is extremely convenient, because you can offload, say, like list management or like Kafka stream, like really convoluted Kafka streams, by just having Lambda functions that, cruise through your data, and they do it at a rate that's acceptable. I totally agree with you. Amazon has not done a good job of really articulating what their vision is for Lambda in the long term. So we don't know if it's going to be so differentiated from Azure serverless functions and the GCP version. But I do think it's incredibly important to understand that anything you can do with serverless, you can do elsewhere in the application stack. It's probably just more painful to do it that way. So it sort of, in that context, it's like where it makes sense, do it. But I wouldn't necessarily worry about about transitions, because like you've got bigger fish to fry if you're going from AWS to GCP. I know, because I've worked at multiple companies that have gone through that transition.
Well, right now, that's my problem, because I'm creating costs on containerization, Fargate, and Lambda right now. And I just deliver it right now in a company. The costs, if you understand the costs, it's not, if you build up this stuff, it's very hard to deliver it. It's very hard.
They're geniuses. They're making the stickiest technology platform possible.
I agree so much with that.
So I mean, I think there's some of that point reflected in my extensively long question, which is basically microservice architectured applications aren't necessarily specifically more complex than monolithic applications or service-oriented applications, but the way that organizations work on microservice applications is different.
I like your son. I like him so much. He's so funny.
He knows I'm trying to concentrate, so.
That's how kids get their attention.
Yeah, everybody loves you, bud. So what are some recommendations you would make to an organization that's starting their journey on microservice apps?
Yeah, so
to avoid inflexibility down the road. Like I've worked for multiple companies that have struggled with changing their core data model or modifying their authentication service. And that's because those aspects of the application are sort of interwoven throughout everything, or they serve as a foundational piece. And so huge amounts of assumptions, like almost like uncountable numbers of assumptions, have been made based off of the original platform decisions, the original data model design. So how do you get to a place where you can actually change those things? Because like those are all unknown type problems.
Okay, so you want to know about the flexibility when you move towards a microservice architecture.
Well, so like if you have a mature, like you guys, right? You have a mature microservice architecture. You have auto scaling. Okay. You've got like a whole deep technology stack. There are certain aspects of your application that probably can't be changed at this point.
Correct. So that's something that I have been to say. It is not possible for you to change your I mean, what is running up and running to completely newer architectures. It will be challenging. It is challenging. Possibly, we may have to see the benefits and move it in only modules, as we were seeing. It could, if you see that you could replace schedule server. If you could replace that, it will not impact your business, because any change that we make, if it is a working application, we should make sure that it doesn't impact our business, it doesn't impact our customers. So you can see where there is a module where you take, it does only collecting from a queue, or it does collecting from endpoints, does some processing and storing. Possibly you can just change that to some function. So change that schedules. Instead of having an entire server, we have done that. I'm talking that based on what we have done it in our own architecture too. We had an entire server to just collect all the endpoint metrics, and we don't even do any processing. It's more like it acted as a queue, because when you started something, you only you don't look at the options. When you start writing a code, you start writing everything as an application and try to deploy it in a server. That's what you do. So that costed us a lot when we had to collect from thousands of endpoints. You have to have the number of servers started increasing. You had auto scaling, and the number of servers started increasing, and it cost us money. That is an area where you could replace it with a function, or you could replace it with just that schedule alone, without affecting the main part, which does all the processing and storing it in the database. So any adoption, for that matter, we have to look at it in pieces and see or take those areas that will not have a major impact and try modifying them and include that. So that's how I would generally see that as. and it should be flexible. It's not rigid. Maybe try that. Possibly if it doesn't work, we may have to change it too. So if we become very very rigid, it is going to be very challenging. So there has to be flexibility in that layer too. Okay.
Thank you. That helps a lot.
Yeah. So we'll go through the questions, Drew.
Yes, I actually feel like that was really the questions. Those who typed it are those who spoke. I'm looking through my notes real quick.
Okay. So I haven't opened them. Yeah, sure.
Yeah,
it's always good to have it as an oral form discussion rather than reading it through. So that's good. Okay.
Yeah, that's everything on my notes, and there's no other ones coming into the chat just yet. So we'll open the floor for last calls, questions, and thoughts.
So, Raji,
Yes.
I'm just curious about your take on host level or kernel level telemetry, because like instrumenting application logging and error frameworks, and that sort of entirely lies with the application team. A lot of cases that's baked into the framework, the application frameworks that they're utilizing. And if it's something to do with like infrastructure as a service platform, like a log you would get from Amazon or Google, they have really rich APIs, but like, what's your recommendation on sort of like reaching into Kubernetes nodes that you manage independently as like EC2 instances, or in your data centers? Like, how are you getting telemetry into the underlying nodes at the kernel level? Because that's like a huge struggle for a lot of
correct. So when you have as you said, the AWS or Azure or Google, they have their own metrics, so they give their own monitoring metrics. At least in our own deployment, see, Site 24/7, we use it for our own monitoring. So Zoho has millions of customers. We have deployments for all our products, and Site 24/7 is used by the IT team itself. We use it as in-house IT team too. So what we do is we have an agent that is installed. So the agent will be installed in your mission, and that will help in collecting additional metrics rather than, see, today. It's more like the cloud providers will be able to give metrics for their whatever the infrastructure that they have. Suppose you take AWS will talk about the EC2 instances or the S3 buckets or whatever you're using. They can give metrics for that. You're not just going to use that infrastructure, and you're going to build application or deploy application on top of it, and that application is going to have a user interface. So you need an entire, you need a tool where you can see the entire layers in all these architecture, and you need to know what is happening in all of them. So that is possible using additional vendors and tools. And our tool has an agent that collects metrics from all these deployed components, and we will be able to use this, and we do some correlation on top of it with respect to the metrics that are being collected from the application, as well as the metrics that are collected from the end users. Your browser components could be anything. So we correlate all this, apply anomaly on top of it, and give it as events and alerts. So that is the help of the monitoring tool. And with respect to telemetry, open telemetry, this is, I said we have an agent. In the industry, if I see now that we have customers who want to adopt the open telemetry standards, and just looking for exporters using which they don't want any vendor lock-in agent to be installed in their application. That is something that is picking up now, the open telemetry standards, which they will do. And they just look for vendors, exporters using which they can export the data into the tool and look at the thing. That is, again, we have customers who are asking, and we are trying to build that.
Awesome. Thanks so much.
Yeah. I think your son is grabbing your attention a lot.
We've got like 5 minutes until he turns into a pumpkin.
Okay, I can understand. I have 3.
Cool. Thanks, Thaddeus. I'll give it a quick pause. I think we're rounding up the end of our time here, but we've got a hot second if there's any more last questions or thoughts.
So even when you put in monitoring, isn't a security issue if you put in monitoring, because it's a hole in your system. Because if you can read everything and you put monitoring in, therefore I'm very concerned about installing it. And that's why problems come into the cloud, really.
Yes. Yes, so it is more like I mean, I will call it as an evolving thing, or it's a more of a cultural mind shift change that has been happening too. Because in the initial stages of cloud, do I have to put my data in a cloud was the fear that people had. It took time, so that's something that I would attribute it to. Having said that, that's why I said security is a challenge and security is important. There are today most of the monitoring tools are on the cloud, so which means all these standards are being taken care of, or the security measures are taken care. To give an example, if it is the agent that you are installing, there will be only one outbound connection which you have to make. There is no inbound that is required, which you will have to worry about, in which could spoil your infrastructure, which you can consider it as a whole. So things on it is a secure one-way communication, which is the only port that you have to open in your firewall, is an added confidence for the people who could use that tool. So similarly, there are other, every vendor runs through all these security measures of making sure, see, the question of you having an agent in my system, will it create any problem? Will it add more latency to my application code? Those questions do come up. So there are testing that is being done to make sure that this doesn't have an impact, because today in a cloud deployment, when you go enterprise, when you want to take your business on a larger scale, after you face a problem, it is very difficult to go and debug it. It's not an on-premise solution where we write log prints, redeploy the code and see what the problem is. It's an on-cloud, always running system. So you must have to find out where the problem is, which becomes difficult after deployment. So performance is always an afterthought, like how security is too. But when you want to, you need to have the help of tools, and when you talk about cloud tools, security is being taken care. That's why we come up with all these standards and certifications and audits, which takes care of reviewing everything. And there are reports. There are security reports that are available based on the questionnaire standards that are available. That's what the industry is doing too. Security is definitely a concern, and that is taken care in the tools.
Do you open up your software for software audits?
Yes.
That's fine. Thank you. That helps, really, honestly.
Yeah.
We have very large concerns at a health company.
We do. That's why I said wherever required, the industry standard auditing and is taken care.
Yeah, the other thing, Peter, is SOC 2 compliance is fairly comprehensive. I've only spoken with a couple of organizations that sort of see that as like ineffective, because it's a measurement of controls and adherence to the controls in a fairly comprehensive fashion. That doesn't mean that it's perfect. Like, you could always have sort of the Circle CI compromise or the SolarWinds compromise where, you know, somebody's build environment gets hosed and then they're shipping a backdoor into your environment. But I mean, if you're not willing to, if you're not willing to take the step into reporting applications or telemetry solutions, then I think you've sort of squared yourself out of like all third-party code. And now you're talking
No. I'm not saying that's bad. I'm not saying like getting a third-party code in here. It's just that if we have the opportunity to scan it for vulnerabilities ourselves,
yes,
is what we're interested in, because we have really high security issues. And right now we have other issues inside of the company, because when you're collecting so much health data, so much mining is going on and too many eyes inside of this stuff. That's the concern right now with this company right now.
I understand. So we do have SOC 2 audit or other certifications and things. And when people want to do it themselves, or they run a report and ask for details, we are open for that. So it's a SaaS company for the from when cloud started picking up. So we have been gone through all this this 15 years now.
Thank you.
Nice. All right. Peter, Thaddeus, thanks for the great questions. Thanks for the conversation. Raji, thank you so much for the presentation. This was really good. This is definitely one of the better meetups.
Thank you so much. Thank you for your time.